Hi, welcome to session 2 for PY0794 Advanced Quantitative Research Methods. So you have a screencast to guide you through these slides, and I'll be narrating them as we go along. It might be chopped into smaller sections for you to be more able to digest it, and you'll see there's some exercises for you to complete as well. So I'll move along. So last week we covered an introduction, and today will be all about visualization. The goal of today is that we gain some insights into data manipulation, data visualization, some basic tests which you should have known from your undergraduate, like t-tests and non-parametric alternatives. And this will also tie in directly to your assignment. After today, you're able to complete some of the following sections: descriptive statistics and data wrangling. You should be able to make a histogram. You should be able to make a violin plot. You should be able to do a t-test and its non-parametric alternative. So we continue with last week. The examples are based on this book and some work by a former colleague of mine, Geert Stolp. And we'll continue with the flights dataset, which you are familiar with from the previous lecture. So this is again how we read in the data, and once we do that, we have a flights database. Now last week we already had a little bit of a play with dplyr. We were able to pick observations based on their values by using filter, and we are also able to do other things with dplyr, like reorder rows. You can read more by click on that link. We can pick variables by their names, which is the select function. We can create new variables with functions of existing variables, so we can make some computations via mutate. We're able to summarize variables, for example, by creating an aggregate, a mean, or a median by using the summarize function. And I'll show you some of these functions as we go on. The first step is to load dplyr. As before, we'll get some warning messages or some messages in general on like which things are masked, for example. And but as in the previous session, you should be able to load dplyr. So we can use select. Select, sometimes you have in your data set 100 or even 1,000 variables, and we can use select to make a smaller data frame. So here's an example. So we can create a new object, flights underscore red, and we can use the select function to select year, month, and day. We can also select all the things going from year to day. Note that I'm overriding here, so this will be now this. And this will, we can also use the minus operation, and then we'll have everything except for everything going from year to day. Okay. So this is the interactive bit. So again, you will have a partner assigned to you. I would like you to load the flights database to make a new data frame with all variables starting from departure time to our delay inclusive. So have a go at that. And this is the interactive bit, which will also be in your worksheet. Moving along, now you have helper functions. So we can have some more complex cases. So we might be able to select variables based on their name because they all start in the same way. So suppose we have a scale on openness and all the items are numbered, open is 1, open is 2, etc. Then we can find something which matches that string. And so starts with, we'll do that. We can also have ends with, we can have contained, and we can have matches. And we can have some very complex functions as well if you have complex symbols. I won't bore you with the details, but you can have something which, for example, looks for repeated characters in your set, and you can use regex, so regular expressions. You can find out more by looking into regex. It's of lesser importance for you now, but you might need it at some point. We can also use the numRange command to return matches. So the example will return x1, x2, and x3. We can use select to rename our variables, but it would drop all the variables which we haven't explicitly mentioned. So sometimes you want to rename some things, and you'll also have something on your worksheet to look at that. and instead we would use rename, which is a variant of select, but keeps all the variable names which are not explicitly mentioned. Perhaps it's better now in the future, but in the past I found it's buggy, so there are alternative solutions. So here's an example where I use the base R solution to this. So you remember that we had year, month, day, and in this case we use names, and this will select those 3 columns, and now we'll have new labels, year, month, day, like this, and we can check that by using head to see what our data frame looks like. We can use mutate, and for doing so I should like to introduce the pipe. So this beast is the pipe, and basically means apply a function to something else. So mutate allows you to make new variables, and so this is an example where we use mutate. So we can do something to our data frame. We say take this data frame, apply something to it, and then we use the mutate function. In this case we're calculating speed, and we're creating log speed, so it gets carried forward. So first we make speed, and then that speed is used later on to calculate the logarithm of speed. So if we only want to keep the things which are calculated, so suppose we want to make a new data frame, then we can use transmute. So that might be helpful for you to use. So again, a whole load of helper functions exists. You can click the link to find out more. The key thing to remember is that you can apply all the functions which we covered last week. So we can use, for example, mutate to calculate means or medians or standard deviations, minimum, maximum, whatever. So one of the things which you might often do is centering your data or standardizing your data. Centering is basically subtracting the mean from your data. It's often used to make scores more interpretable and also to avoid collinearity. We'll return to that. It's a big deal, and we'll discuss more about it when we discuss ordinary least squares regression or OLS regression. But for now, you should know that you can center your scores. And it helps with interpretability, for example, because we're now interpreting shifts away from the average rather than an absolute shift from 0, for example. We can also standardize, and we can use the scale function in order to do that. You might remember set scores from your undergraduate. So here are the examples on how we how we perform centering and standardization. And again, pay attention to the fact that we use an a.rm is true to avoid issues with missings. So this removes any missings for the operation, because otherwise, if there is a missing, then it would return an A for all those data points. And just a reminder about set scores and how they work. Again, go over your undergraduate notes in terms of how set scores work, but basically it's rescaling everything so that the mean is now 0, and 1 means being 1 standard deviation away from the mean. So we can also use summarize, and so we can get 1 row with a summary of our data frame. So in this case, in the example, I've calculated the mean speed, and then if you look at that, the output will be this value. Summarize by itself is usually not that useful, but it is useful when we combine it with something else, which is group by. So we can tell R that we want the data set to be structured by carrier. And these are all potential carriers like 9EAA. Having AA is American Airlines. They're all abbreviations. I think DL might be Delta. So they're all abbreviations for airlines. So we group the data by this, and we make it into a new data frame, which we call by carrier. And then we can summarize, and then we can have a look at the mean departure delay as organized by carrier. Again, this is the interactive bit. I would like you in this section to calculate gain, which is arrival delay minus departure delay. I'd like you to calculate airtime hours, which is airtime in minutes divided by the number of minutes in an hour. I would like you to calculate gain per hour, which is gain divided by airtime hours. And then I would like you to standardize gain per hour and use group by to calculate the means of gain per hour by each carrier. So these are all operations which you've seen in the previous slides, and I would like you to apply them. Moving along, often what we want to do also with our data is replace missings. For example, we want to replace the missings with the means or the medians of a score. So how would we go about doing that? And this is where we use mutate again, and we use if-else to replace with the mean, and then otherwise it will use the departure delay. Yeah, so it will make a new variable, departure delay no missing, and it will use the mean if it was missing before. And in that case, we don't need to add the na.rm is true anymore, and this will be the mean once we've imputed the means for all the missing cases. The other thing you might notice here, and it's in a different color, is that we can abbreviate true to T, and false we can abbreviate to F. So far so good. Now that we know the basics of manipulating data frames, we can have a look at making graphs. So why is your plotting your data so important? It's because of Anscombe's quartet. You can have a look there, but Anscombe's quartet is basically a set of relationships which have the same overall correlation. As you would say, that's quite a good correlation, especially for a psychologist, but they look very different. So these are 4 panels, and you could see very different distributions underpinning it. So probably we would want it to look something like this if we're looking for linear relationships, but it could be curvilinear, it could be driven by a single outlier, or it could be bimodal, and in this case you also have a single case which is driving the effect. So often it's important to plot your data before you go and do your analyses. So that's why we'll pay some importance to looking at plotting data. There's an extension of Anscombe's quartet, which is the data source. You can look at this, but basically we can generate data sets which will resemble any type of potential pattern, even though they have the same overall metrics or the same overall correlation. So now we'll make some graphs. You remember ggplot2. We also have some helper packages. We have scales, which helps with our axes, our color brewer to help with some colors. We can use GG teams to allow some standardized templates, and cowplot to allow paneling of graphs, so basically putting them next to each other. By now you should know that we can call these things via library. You could also use require. I've talked about this difference in the previous lecture. So let's make a scatter plot. Our data set is truly massive, and for this exercise we're just going to select all the flights from JFK Airport on Christmas Day. So how do we do that? We take the flights database, we use filter, we select the month and the day, and we select the origin being JFK Airport, and that will give us a data frame which have all the has all the flights leaving JFK Airport on Christmas Day. We can quite easily make a scatter plot. So the way it looks is we use ggplot, we use flight JFK new as the database. We say these are the aesthetics. We tell it what the x-axis is, what the y-axis is, and then we tell it the type of graph we want, which is GM point. And then we'll have something which will look like this. Now we had a warning about we have 2 missing cases, and that has been helpfully mentioned to us by ggplot. So we'll replace those. In fact, we already did that for departure delay, but that was based on the whole set. For this exercise, we'll replace it again. So now that it's replaced with the mean on Christmas Day for JFK Airport. So it's not the mean that we had from the previous data set, but it's the correct one for this data set. So this is similar to the code which we had before. So have a look, but this will replace the missings for departure delay and for arrival delay. Now we can plot it again. Now we no longer have this warning because we've replaced the cases. You can see now it says departure delay no miss and arrival delay no miss, and we have this graph with all the points there. So we can color it by airline. So we have something like this type of structure, and then in the aesthetics we've just added the color of the carrier, and now we can see the coloring by carrier. And again, we can store this into an object, for example, and then we can tell the object what it should be. So plot geom point will turn it into this type of scatter plot. So that perhaps wasn't really clear, but we can store any type of thing like we do with a data frame into an object, and then we can further manipulate this object to get the graph which we want. So the beauty of this is that we can use a different command to sort of change this plot. So this is returning to the previous plot, graph delays, we add geom count, and then we can get a bubble plot. So you can have a look at all the different possible geoms, but we can relatively easy change the layout of a graph by just saying which type of function it should be via the geom command. So here's another one. In this case, we had add count, and we also added a smoother to it, so we can make lots of combinations of different graphs relatively easily, which would be a lot more difficult to do perhaps in some other software programs. Here it's just adding a line of code or adding an expression in terms of geom to it. Again, I would like you to try it yourself. For this exercise, I would like you to make a similar set as we did, but now we want flights leaving LaGuardia Airport on Christmas Day. I would like you to make a plot with departure delay on the x-axis and speed on the y-axis, and I would like you to color the point by carrier. Okay, so now that you've done that, we can tell you a little bit more about the ggplot. You can basically change anything you want. So in this first example, you could see that I've made just a selection of 2 airlines. I said it should be DL or UA, and that would be, if I'm not mistaken, Delta Airlines and United Airlines. We then use this new data frame to make our initial plot. Then we can make some points. We can change the size and shape of these points by these type of commands. We can also change the transparency via alpha. We can add a smoother to it, but in this case a linear regression line. We can change the color. So we can say scale color brewer, and then we can pick a palette. In this case we're selecting the set 1 palette. We can change labels to something more meaningful. We can add a title, and we can change the theme. So we can change the sort of background. You remember that we had a gray background, and we might want to have like a more black and whitish theme. So if we do that, we get something like this. I've called it beauty because it's an absolute beauty supposedly. So we can change all aspects you want to graph to make it basically look any way you want. And that's the beauty of using ggplot to make all sorts of different graphs, and that's why also it's been commonly used by researchers but also by journalists to make lots of really pretty looking images. Now I'll return to this bit about making many types of graphs. You can do all sorts of different graphs. We can use all sorts of setups in terms of geom density, geom histogram. So they will all generate different types of plots for you. You can have a look at the manual. I won't go through all of these now. So you can have error bars, for example, all sorts of other commands. I will not cover all of these today, and perhaps also not in all the future lectures, but have a look at the manual if you want to find out more. You can find more also by clicking that link. So let's make a paneled histogram comparing delays in departure of 2 major airlines, JetBlue, code B6, and Delta Airlines on Christmas Day. To help ourselves, we'll make 2 separate data sets. So in this case, I've opted to make a data set for Delta and one for JetBlue. So, oh, this is going the opposite way. So note that now I went for short names. So I've called this JFK Delta and JFK JetBlue. Again, it's taking our previous data sets and then it's filtering based on whether it's a Delta or a JetBlue database. And then in this case, I've chosen to also write away the data, what we did. So that's usually quite a good strategy also when you have graphs which you're making, so that you can reproduce the graph without loading all your data sets, but you have the data stored away somewhere as a comma separated value file, like a .csv file. Now we can make some histograms. So in this case, we can make a plot delta and a plot JetBlue. In this case, we're moving along with the blot delta. In this case, we use Geom histogram. We tell it to make the surroundings of this bar black and to fill it with white. And then we get this, and then we get some type of warning, which is always interesting. And it's telling us which type of bins it's using. It's basically telling something about the size of these bins in the chart. So it's using defaults, which is it's important. Bin width is also important. You want it to be not too large or not too small. I wish I could say there's always an optimum value for this, but you're going to have to look because it will depend on your data. And in this case, we can change it. For example, bin width is 1, but we can also change it to bin width is 40, and we get very different looking graphs. So this is basically how many cases we're allowed to group together. So in this case, I've settled on 5. Some of these choices are arbitrary, but then you get a perhaps relatively okay overview of the distribution, which you can compare. So we have delta in this plot, and we have JetBlue in this other plot. And I'll just scroll so you can see the entire code, but there's nothing really surprising there. We can change the labels, so we can change that via xlab. So in this case, I've changed it to departure delay and said this is delta and this is JetBlue. We can change how the axis ticks work. So you can say whether the y should be continuous and how it should go. And you can also change how many breaks it should have with pretty breaks. So you can have a look. So in this case, for example, we go, in this case, I've manipulated the X thing and it goes from -20 to 300. And I've told it again how many breaks ideally we want to have. So note that the intermediate formatting gets lost, and in the end we need all those commands in one go, or we need to store those intermediate graphs and update those. So if we want everything to look like that, we need to store it into an object and change that object every single time. I can tell you a little bit more about teams. So we can have all sorts of teams. In this case, we can have something that looks very closely to Google Docs. And in this case, using base size, it will determine the font and how large this font is. So again, we can use this in combination with other things as well to first make the chart sort of look the way we want it to look, and then we can apply a theme to it to make it look consistent, for example, with a Google document or with something else. So in this case, like I said, because it will forget all the intermediate formatting, we're applying all those things which you saw before in one go. So you can have a look, and then we end up with something like this. So again, this is the interactive bit. I would like to try it yourself, that you would have a go at this yourself. I would like you to make a plot for JetBlue, similar as the one I've done for Delta. And don't peek ahead, but here's the solution. We can save it. There's all sorts of ways to save it. We can use ggsave plot jetblue.pdf. We can specify the width and the height in millimeter. You can also use inches or other setups, like if I'm not mistaken, you can also say pixels even. So you can just have a look at what type of units are available to you. The default is that it will save the last plot displayed, but you can also explicitly name and say the object of this plot and then say save that plot. You can change what I just said. You can change the output size to different units. You can change the resolution by looking at dot per inch, DPI, and you can save it in many different formats. In the example, I've saved it as PDF, but other common formats would be .png or .tiff. And by default, it will be saved in your working directory. Again, you can change where it should go by changing the path, which you might have done previously. Now we can combine multiple charts also together. In this case, we use plot grid. This is what we call a cow plot. And in this case, we've taken both the Delta Airlines plot and the JetBlue plot, and we've put them next to each other. And we've put labels of A and B, so you can see A and B. We've set how big those labels would be and whether they would be aligned horizontally or vertically. In this case, it will also save this plot in this type of dimensions. So it's also relatively easy or before you might have had to rely on like using your paint skills or your Adobe Illustrator skills to combine plots. It's relatively easy to generate plots which are next to each other or which are combined if you need to make a multi-figure figure for your paper. So if you want to have a figure which has many figures in it, it's relatively straightforward to do that in R, which is again one of the benefits of why we're using. So how you go about and interpreting this, perhaps this chart is not the most optimal one. I'll leave you a moment to decide, but perhaps the key thing you might pick upon is that most of the things for delta at least seem to be quite condensed, but you have some outliers. Some people have to wait for nearly 250 minutes. So you could see there's also some tails here, but you don't have as extreme perhaps as going to 250 minutes. So what is good and bad about this chart? I would say it's perhaps quite clear, but we only have two groups, so we could potentially overlay them. You should also have spotted perhaps some imbalance between the absolute number of flights between United Airlines JetBlue and Delta. So we have varying N and varying sample sizes, so perhaps it's not optimal to use it in that way. We have quite a lot of white space, so we could still try and improve this. We also used minutes. Perhaps we could put that on the x-axis chart. So I've also suppressed some missing values, perhaps because binning can obscure those. So it's not always a major issue, but something to consider. So that was a little bit about histograms. So just to say, the examples I've shown you, you could always think of better charts. And I challenge you to have a go at making even better charts. So you might have not heard of violin plots, but we're going to move on to violin plots. We can approach the data in a different way. And basically we can make a violin plot, which is a box plot, which you remember from last week, with some additional information. And that would give us a good overview. So how do we go about doing this? We take the two data frames which we had before, and we use rbind.data frame, and R stands for row binds. We could also bind columns, and we make one thing which is going to be violin plot data. We want to then make some labels. So we want to make a variable which is carrier, which recodes our previous version of carrier, and by putting in JetBlue and Delta Airlines, we now will have some labels to put on our chart. Now making the actual plot is relatively straightforward with ggplot. Again, we can use +gm violin, and we can tell it to have a box plot, because otherwise we'll just have the outside shape but not a box plot. And we can say how wide that box plot should be. You can toy around with those values to see if you get different results. So here are the results, and again you could already see quite this longer tail in terms of the extreme values with Delta Airlines, which was also present in the histogram. We can add some oomph to it if you want. So if your supervisor is a Stata user, you can have something which looks like Stata. We can change the Y-lap, so we can change the Y-axis label, and we can change the X-axis label, as I've done in the example here. So again, you can beautify your plots via various themes to make it look the way you want it to look. So I'll leave this for you, and perhaps also for your worksheet. So can you describe the graph? What are the key points? And yeah, hopefully we'll have noticed some important things about these plots. We can change the order. So suppose your supervisor is unhappy and he wants to have JetBlue on the left-hand side rather than the right-hand side. Then the easiest way to do this is to actually fix the data set. So in this case, we use Haven. We recode carrier. We say it's a factor by using as_factor. And then we tell it the ordered levels it's supposed to be. And then we can do everything in one go. So we can say mutate violin plot data. Again, reminding it's a factor, take carrier recode, and use these type of levels. So some of these steps could have been combined, but here I've just done multi-steps to get to this goal. We make a violin plot 2, In this case, we use the recoded carrier. And now you can see, because we reorder to levels, JetBlue will be on the left-hand side and Delta Airlines will be on the right-hand side. And again, we've used here this data team to make it look slightly prettier. It's a little bit squashed in the rendering on my slides, but trust me, it will look nice if you were to do it in RStudio. Now, moving from actual graphs to actual tests, you might have had some questions about this already, like, are there differences between these two airlines by looking at the graphs? And so you might have had some ideas about this. You could see quite some overlap. So we could do a t-test, and you might have done these in SPSS before, or perhaps even Excel. And in R, it's relatively straightforward to do a t-test as well. All we need is this one line of code with like t.test. We tell which one is the dependent variable, which one is the independent variable. The tilde sort of indicates the relationship between the two. And it will say departure delay by carrier. So that's the independent variable carrier. And we also tell it which data frame to use. And then we have some output. It will tell us the t-value, degrees of freedom, and the p-value. It will also give us the mean estimates for both groups, for Delta Airlines and JetBlue. Yeah. And so it will also give us the 95% confidence interval of the difference between the two. So let's break it down. We have dependent variable followed by independent variable. You might have seen this, but it said Welsh correction. So it said Welsh to sample t-test. That's quite important. So what this test does is, like, if we were to compare this to your SPSS thing, it's like this would be the t-test corrected for the assumption of equality of variances. So so remember that when you have your SPSS output, there would be a solution which says when there's no violation of the equality of variances and when there is a violation of the equality of variances. This one takes the more conservative route and always assumes that the variances are not equal. This should be the default for most things which you do, and you can check some papers on this, on why this is the default option in R. Now, we had the means, but we didn't have a standard deviation, so we still have to calculate those. And you can see I've calculated those here via using the codes which we had in the first slides. And you could also see that the standard deviation is substantially larger for Delta than it is for JetBlue. So how would you then write this up? This is something you've done many times, perhaps also for your thesis. And so you would write it up as follows. An independent samples t-test was used to compare the delays in departure between Delta Airlines and JetBlue in minutes. And then you can write the results like this. And it's important to pay attention to the utilization of, for example, means, but also the t-value and the p-value. So pay close attention to those because the APA really cares about that. Now we've used the t-test, which is a parametric test. We can also use non-parametric tests. So these there are assumptions associated with parametric statistics. The most important one is that they're normal distributed. You remember our chart. That might not be the case. We had quite a long tail and it didn't look all that normal. So it could be useful in our case because we had some very extreme values. So we could have opted perhaps to remove those outliers, but we could also figure out a way to analyze the data where we don't care as much about these extreme values. For example, by using a non-parametric test. So the downside of this is, and why some people might not like non-parametric tests, is because some information is lost, and often these tests are less powerful to detect significant differences between groups. But let's have a look anyway. So other alternatives exists to your t-test as well, but we could, for example, do a moot median test. But one common test is the Wilkinson-Mann-Whitney U. Sometimes you will have seen it called just the Mann-Whitney U, perhaps from your SPSS days or from your undergraduate days. In R, the code is wilcox.test, and it's the similar type of formula that we had with t-test. And again, you have to tell it which type of data to use. Now, interestingly here is that you can see we have a significant effect here. So depending which test you would have chosen, you would have had a very different conclusion on whether there were significant differences between JetBlue and Delta. So we can also use another thing. In this case, we have to tell it that carrier is a factor. And so in this case, I'm using a cross-call-Wallace test. You can read more about that particular test by clicking the link. And again, the conclusion is similar. There is a significant effect between these two airlines. In your report, we would typically report the medians. So the median is 1 minute for Delta and -1 minute, so actually leaving slightly early for JetBlue. And your APA style write-up would be as follows. Wilcox and Mann-Whitney used showed that there was a significant difference between Delta Airlines and JetBlue, but you can sort of see that in absolute terms, the difference between the medians is the difference between 1 minute delay and leaving 1 minute early. But the conclusion overall is that Delta Airlines is significantly later than JetBlue. So again, the lesson here is that perhaps based on the test you would have picked, you would have had very different conclusions. Now, this is going to get a little bit more complex. I might ask you to do some reading and reviewing some things as well. What we could also do is we could bootstrap our results. And bootstrapping is basically sampling with replacement. It is a non-parametric technique, so we don't need to make any assumptions. Basically, we use our own sample, and by repeatedly drawing samples from our own sample, we calculate a statistic, and we can then have some measure of uncertainty. And the beauty of this technique is that it can be applied to nearly any technique or any type of data set which you have. Presumably you don't want to use it on very, very small data sets, but it's very nice to basically be able to estimate how much uncertainty there is based on your own data. In the past, we weren't always able to do this because it would be very tedious to do it by hand and writing out all the different combinations and basically rolling the dice every single time and selecting a value and then building this over and over. But now we can quite easily ask the computer to do something over and over 1,000 or 10,000 times for us. How to do it? In this case, we use the boot package. You can again read more by clicking here. We make a function with 2 arguments to do this. We need some data and some indices, and we will then feed that data to our function. And so there's quite a lot of things going on here, but I'll just run you through it. The key thing here is that we basically do the t-test, but then do it over and over, and we build a function to do that for us, which uses data and indices. And that function will return something, and in this case, we want the third position from the output, which would be the p-value. So you can look at how the t-test object is structured, and then find a position where something is, and then these double square brackets will allow you to select that element. Now, bootstrapping is truly random. I've not updated this, so it's still 2019. So, but it's important to use set.seed to make sure that we get the same results every single time we run it. So if I had put a different number here, we would get very different results every single time we run it. Now, to run it, we can do results, boot, we feed it to data, we say which statistics it should be and how many bootstraps we want. So sit back and wait for a little while because it's going to take some time when it's doing this t-test 10,000 times, and every single time sampling from original data and then calculating the p-value. But that's the beauty of computers. So we can look at, this is the original value which we had, and then these are all these 10,000 bootstrap things, and so sometimes we get 0.09, sometimes we get 0.44, etc., etc. So it's not printed all here, but you would be getting up to 10,000 of these cases. It might be useful to plot these results, and this is sort of what they look like. And then we can create 95% confidence intervals for P, because, for example, we have 10,000 of these cases, and we can then get those confidence intervals for the p-value. You can read more about different types of confidence intervals, but one of the best methods is using bias corrected accelerated. Again, I won't bore you with the details, but you can have a look and you can have a read. But based on some simulation studies, it seems that this is a very good method for creating confidence intervals. So in this case, we ask for boot.ci to get the bootstrap confidence interval, and this just denotes that it's bias corrected accelerated. So it's using those 10,000 samples, and then we can see this is the 95% confidence interval for P. So you can see it's really, really wide. So how would you write it up in your report? So you would say the 95% bias corrected accelerated interval for the p-value was 0.006 to 0.857. And that's using 10,000 bootstrap samples. So I would like you to do the same, but now do it for delay and arrival. So I'd like you to also use the bootstrapping function to do that t-test and to bootstrap it. And that's actually the end of this session. Again, as with the first session, there is an exercise for you to complete. I would like you to install and load the car data package. This dataset has 39.7 cases and 6 variables. I would like you to have a look at that dataset. You can perhaps use Skimmer as you did in the first set of slides. We can calculate the monthly salary and note that these are 9-month salaries. I would like you to make a beautiful scatter plot. I would like you to color that scatter plot by gender. I would like you to make a paneled beautiful histogram with the distribution of salaries by academic rank and save it somewhere. So again, these are all things which we've covered in this lecture, which you can now test for yourself on a different data set. I would like you to make a beautiful violin plot with gender on the x-axis and monthly salary on the y-axis. I would like you to test whether men earn more than women do in this data set. I would like you to use a parametric test and bootstrap it, and also to use a non-parametric test and report as you would do in an academic paper. And I would also like you to think and discuss, like, why is it good or bad testing the data in this way? Does it matter if you had used a parametric or non-parametric test? And as a bonus, I would like you to calculate the mode, so the most frequent value of monthly income for each gender. I would like you to calculate the 95% confidence interval for the mean of monthly income for each gender as well. And that's it. And here's some references and some further reading. And I hope to see you all again next week. And these are some acknowledgements. So the slides were built in Sarangan, and I would like to thank Gerstel for some advice and some code for the ggplot2 section of this lecture. That's it. I hope to see you all for the online classroom session, and good luck preparing and good luck with the exercises. Bye.